today's webinar. Thank you very much for joining us. My name's Jack Henriquez. I am a product manager for Altium, and today I'm going to be talking to you about how to edit your PCB geometry using MCAD tools. Okay, I'm going to start off by looking at the traditional PCB design flow. This diagram shows the workflow for creating a PCB, starting with a schematic creation, flowing through the process, finishing off with the preparation of the PCB design files for manufacturing. There are two stages in this process where we'd expect to see significant mechanical input. The first one of these is the board shape definition. Obviously, most PCBs are designed to fit in some sort of housing or enclosure in a product. So obviously the mechanical engineer is going to have a big influence on the shape of the board, the shape that it needs to be to do that. Not only the outline of the board, but the size and position of any mounting holes and any cutouts or anything needed to interface with the other mechanical parts of the assembly. The other one of these areas is the component placement. That was covered in the previous webinar last month, so I don't propose to go into that in any more detail. But what I'll do now is just show how CoDesigner fits into this process. CoDesigner allows the mechanical and the electrical engineers to work together during these two phases of the PCB design process. It also, you can actually also create a PCB in CoDesigner from scratch. It allows you to do that, but there are some advantages to creating an ECAD first and pushing it to CoDesigner. One being the definition of the layer stack will be there in the board right from the start, and it also allows the use of some of the ECAD templates. I'm going to just quickly go through the traditional PCB geometry creation, how that process looks. So the mechanical engineer will define the shape of the board in the context of a higher level assembly in the MCAD package, as I've just talked about. They then need to export that definition, that board shape definition, into some sort of file format and make that available to the electrical engineer, who then needs to receive that information, save it somewhere, and then use it in their ECAD package to recreate the board geometry. It's a labor-intensive process. The files have to be exported and created. They have to be manipulated. They have to be sent and received. And because of that, it's hard to manage. You can have, you're relying on files being attached to emails, the emails being sent. You've got to keep track of the latest files. You've got to look after the file revisions, and because of that, the process it's prone to errors. It's easy to attach the wrong file to the email, not look at the latest, most recent email you've been sent, save a file somewhere and accidentally overwrite another file, pick up a file from a wrong directory, and there's a lot of opportunity for human error in this process. Before I move on to the next slide, I'd just like to ask you to take a moment to fill in our first poll question, if you wouldn't mind doing that, which should pop up on your screen any moment. My colleague Nikolai Nurkov is posting up the poll questions for me, but he's also online answering any questions in the chat. So if there are any questions, there'll be time for questions at the end, but if you have any questions as I'm going through the slides or the demo that I'm about to get onto, then please post them in the Q&A section, and Nikolai will do his best to answer them as we go through. So thanks for that, Nikolai. Right, I'm now going on to look at how that process changes when you use CoDesigner. Now, the mechanical engineer's work remains the same. They still define their board in their MCAD package in the usual way. But the difference is, once that design is done, instead of having to click to export that information to a file and then do something with that file, all they need to do is click the push button in the CoDesigner panel in their MCAD package, and that will be received by their electrical colleague in Altium, and they just click apply, and the board geometry is recreated within Altium. It's an instantaneous process. If the electrical engineer happens to be working in Altium at the time that the mechanical engineer makes that push, they'll see that push come through straight away. If they're not working on the project at the time, the next time they do work on it, that the push will be a notification waiting for them that they'll see next time in the panel as soon as they start working again on that project. It's easy to manage. There's no manual dealing with files and emails and attachments. It's all just the information is all just transferred seamlessly, and it's error-free. And obviously, as with any system, you can make a mistake using it, but the actual transfer of the information itself, it's all automatic. There is no opportunity for human error. I would like to ask Nikolai, please, would you just put up the second poll question, please? And once again, I'd be grateful if you'd take a moment to answer that for me. Okay, I'm going to now move on to a live demo and show you the some of the principles that I've just talked about. So my starting point for the demo is I'm in Altium now, and I've got a PCB project which consists of a board with a component on it. And this board only exists in Altium at the moment. It doesn't yet exist in MCAD, it doesn't exist in CoDesigner. So the first thing that I need to do is push the board to CoDesigner. So I'm just going to click push, and any time I push anything from ECAD or from MCAD using the CoDesigner panel, I have an opportunity to attach a comment to that to tell my colleague what it actually is that I'm pushing. So this is the first time I've pushed this board, so I'm just going to push it with the comment initial push. And I'll just wait for a moment for that to go through. And what it's doing now, it's packaged up the design information, and it has sent it to CoDesigner, and I can see that's gone through successfully because it shows in my activity history in the CoDesigner panel. So now switch to SolidWorks. I've got I'm working in an assembly, and in that assembly at the moment, I have an enclosure base. I don't yet have a PCB in this assembly. So I need to go to my CoDesigner panel, click pull board from server, choose the project that I've just been working in Altium, and I need to save this assembly somewhere. So let's just save it anywhere. And the board is now being recreated in SolidWorks by CoDesigner. And it's not just pulling in some 3D step file or anything like that. It's actually using native SolidWorks commands to recreate that board in native SolidWorks features. So I'll just take a moment to do that. We can see the board's there now, and it started to create the footprint, and there it is. That's done. We've got the board with the footprint in SolidWorks. So I'm just gonna save that. What I do need to do now is put that board into my assembly. So I'll switch back to the assembly, and I'm going to click Insert Components, which should do. Now that should bring up a bring up the boxed asking me to choose the board. I'm not sure why it's not doing that. Bear with me a moment, sorry about this. Sorry about this. I'm just going to quickly restart my SolidWorks. Apologies for that. It's the nature of doing live demos, I guess. I've been practicing this all day, and every time I've done it, it's worked fine, and come to do it live and it doesn't work properly. So SolidWorks is just starting on my other monitor. So once it's there, I will pull it back onto this one, and hopefully we can continue. I'll just take a moment to look at the questions. See, there's one. Does this work on Siemens NX? No, it doesn't at the moment. I believe Nikolai has answered that. Thank you for that, Nikolai. Right, I'm really hoping this works this time. I'm going to go back and open my assembly. And insert component. There we go. It worked. There it is. Phew, getting worried then. If that didn't work for that time, I don't know what I would do. Right, back to where I was. It's a bit of a distraction there, but hopefully we'll get going again now. Right, I've got my my PCB assembly within my top level assembly now, and at the moment it's not constrained anywhere. I can just move it around. So the first thing I'm going to do is constrain it in the Z direction. So I'm going to create a mate between the bottom surface of the PCB and this surface on the assembly. And there it is. So what I can do now is I can move the board around in the X and Y directions, but it's constrained in the Z direction. So what I'm going to show you now is how I can recreate this board line by using the enclosure as a reference for that outline. But before that's going to involve deleting the existing board outline. So I'm just going to move the board so the components somewhere within the enclosure, which is where I want it to be. So when I recreate the board, it's still on the board. I need to stop this board moving around. So I'm just going to create another couple of constraints to hold it in place. So I'm going to create a distance constraint between this assembly plane and the parallel plane in the PCB assembly. And that's defaulted to coincident, but I want to just click on the distance and put that back to where it was before. And I'll do the same with this plane and this plane. Put that back. So the PCB assembly is now fully constrained within the top level assembly, and I can't move it around anymore. So I'm going to go into this in the model tree here. You can see the PCB assembly. This is the PCB part within that assembly, and here is the board, the extruded feature that creates the actual board. And the sketch, I'm going to go into edit the sketch that defines that extruded feature now. So I'll click that, and let me just get a nice top-down view. There we go. I'm going to delete this board sketch, and I'm going to use a tool in SolidWorks called Offset Entities, which allows me to select some edges on the enclosure and use those as a reference to create the new board shape. So I want it to be, let's say, 1 millimeter within the edges I'm going to select. So I'll just go around and select these edges in order. So this is a nice way of doing it. I'm not having to manually draw and dimension anything from scratch. I'm just completely using the enclosure as a reference. So I'm happy with that. I'm happy with those lines. For this edge of the board, I don't want it to be a millimeter in. I want it to be flush with the edge of the enclosure. So I'm just going to get my line tool and finish off this outline. And I'm happy with that. So there we have the new board shape to fit perfectly inside the enclosure. Obviously, I need to mount it in the enclosure somehow. So if I just hide this for a moment, you can see there's some holes there in the enclosure, which I can use for my mounting holes. So I'm going to go back into the board part and edit that part. I'm going to go to the hole wizard and put some holes in it. So let's say, yeah, 3 millimeter holes through the whole board. And I want to make those holes from the top surface of the board, obviously. Let me just change the view style so I can see the holes in the enclosure underneath. I can use these as a reference for the hole locations in the board. So as I move the mouse over these holes, I can snap to those points and use them as references. So let me just do that for all 4 holes. Last one. Okay, happy with those? Click OK. Go back to the assembly editing mode. And let me just shade it so you can see it a bit better. There we go. I've got my 4 holes through the board in line with the holes in the enclosure. Now, before I push this back to Altium, there's a couple more things I want to show you. Firstly, let's imagine that this enclosure is mounted on a wall, and coming out of a wall, I've got a cable, and this cable needs to feed through the base of the enclosure and up through the PCB and be wired into a connector on the top side of the PCB. So I'm going to work within my top level assembly. I'm just going to save this before I do anything else. Always a good thing to do. I'm in the top level assembly, and I'm going to use an assembly feature. I'm going to create an extruded cut in the base of the enclosure. So I'm just going to draw a rectangle and for that cut, and let's put some dimensions on it. Let's say 20 millimeters from this edge, 20 millimeters from this edge, and make it, say, 10 millimeters by 15 millimeters. Obviously, you couldn't actually create a cut with these sharp corners. So let me just put a couple of, say, 2 millimeter fillets in these corners to make it something that could actually be manufactured. I've now defined the sketch for the cut, and I want it to go through the whole assembly, so the enclosure and the board. Something I'd just like to point out at this stage, there's this feature here, this option, propagate feature to parts. Now, if I don't select that, I'll show you what happens. This cut is, in the context of this assembly, this cut exists and it goes through the whole assembly. But if I now open the board part on its own, that cut isn't there, which means it wouldn't get pushed through CoDesigner to Altium. So I need to actually go in and edit the definition of this cut, and I need to select propagate feature to parts. What that will do is make sure that when I open the board part, the cut's actually included in that part. So I'm just going to save that. One more thing I want to do before I push it back to Altium, I'd just like to move this component up to where I want it. So to, as I said before, component placement and constraints was the topic of the last webinar, so I'm not going to go into any detail on this. I'm just quickly going to go into my PCB assembly, edit the assembly, and create some constraints between, say, this, oh, not that bit, apologies, this face and this front edge of the board. Let's say I want them to be coincident. And I also want the component to be, say, 25 millimeters from that edge. This component now is fully constrained on the board in the X, Y, and Z directions. I didn't need to create a constraint in the Z direction because that's already been done for me by CoDesigner. That's done automatically. When I push the board from Altium, CoDesigner reads the component standoff height from the top of the board and uses that information to create a native constraint in SolidWorks. So that component is now fixed in all three axes. You'll see that the footprint hasn't moved with the component, but that's fine. That's expected behavior, and that'll be resolved in a moment when I push it back to Altium. So that's what I need to do now. I need to push this board back to Altium. I can't do this at the moment because I'm in the top level assembly. I don't have access to the CoDesigner panel. Well, I do, but I can't do anything with this assembly. So to get access to what I need to open the PCB assembly on its own. And once I do that, the CoDesigner panel will, sorry, pop up another window. The CoDesigner panel will update and give me access to the workflow that we were working on. So I'll push these changes back, and I'm going to say we've done quite a lot of things. We have redefined the board outline, created mounting holes, moved and constrained USB 3 connector, and created cutout. I'll push these back to Altium. They've gone. If I switch back to Altium now, we're doing a bit of work on the server at the moment. So what normally happens is a notification will pop up in this panel telling me about those changes that have just been made in SolidWorks. That's not working at this precise moment due to something that's going on with the server, but that's what would normally happen. So just for the time being, I need to click pull to see those changes. And when I do that, those changes are pulled in, and I can click through them one by one and see the preview of those changes in my PCB document. The first one is the new board outline, the new location of the component, the four holes, and the cutout. So let's just apply those. And the changes show in my activity history, and we can see them in the board. So that's worked well. The component footprint has now updated with the position of the new position of the component that was defined in SolidWorks. So I need to, in order for that footprint to be in the right place in SolidWorks, I just need to push the board back to SolidWorks from Altium. But before I do that, I would just like to show you one more thing. If I go into the layer stack manager now and change the board thickness, let me change that to say 150. Pretty thick board, but just so it's easy to see the change. Close that, save the changes. See the board's much thicker now. I'll push that back and I'll say modified layer stack, and what else have I done? I have, well, the footprint will be updated. And I'll push those changes back to SolidWorks. While we're just waiting to go back to SolidWorks, Nikolai, could I please ask you to put up poll question number 3? And once again, I'd be grateful for some answers on that. I'd be much appreciated. Okay, let's go back to SolidWorks. We're back in the PCB assembly now, and straight away I can see my notifications that we've just the changes we just made in Altium. So I'm going to view those, and this warning that pops up, that is because it's telling me that that J1, this connector, was moved in Altium, but we've constrained it in SolidWorks. Now that's completely expected because J1 is its position has changed because of the board thickness has changed, and the component is obviously remains the same distance above the top surface of the board. Then if the thickness changes, obviously the component moves up accordingly. So that warning is what I would expect to see in this case. So I'll just click OK to that, and I will apply these changes, and you'll see them. You'll see the board gradually being updated. Should see the component holes move in a moment, I think. Yep, there's a board thickness. You can see the board's thicker, footprint's moved, and the component holes have moved as well. So that board is now completely in sync between AD and SolidWorks. I'm going to just go back to the assembly, and there we go. We can see all those changes updated in the assembly. One thing I would just like to point out is if once the board outline has been defined, or once anything has been done in MCAD in relation to the board outline. So if, for example, constraining the position of any components or any holes or cutouts, any changes to the board outline that need to be done from then on should be done in MCAD. What will happen is if any changes are made in Altium, when those changes are pushed to MCAD, the board outline, instead of just being modified in MCAD, it will actually be deleted and rebuilt from scratch, which means all the internal edge IDs in MCAD will change, and all of the constraints that relied on those edge IDs will be broken. So it's just something to bear in mind for your workflows. That takes me to the end of the demonstration. I'd like to move on to some questions. Before I do that, Nikolai, could you please just put up the final poll question? That'd be great. Thank you. Any questions? I think I'm just going to have a look at the panel now. I see that there were a few and they've been answered by Nikolai. So I'm very grateful for that, Nikolai. Thank you very much for that. If anyone has any questions in the future, my email address is at the bottom of the slide there. Please feel free to drop me a line. If I can't answer your question myself, then I can certainly refer it to someone else and get an answer for you.